Hello and welcome to the session. In this session we shall discuss how to graph the inverse of a given function whose inverse exists and finding an invertible function from non-invertible function by restricting the domain. First of all, we shall discuss graph of inverse function. Suppose we have a function f of x whose inverse exists. Then the graph of f inverse is obtained by reflecting the graph of f across the line y is equal to x. Now, to graph the inverse, that is f inverse function, we interchange the points on the graph of f to obtain the points on the graph of f inverse. For example, if point with coordinates 1, 2 lies on graph of function f, then point with coordinates 2, 1 will lie on graph of function f inverse. So, reflection in y is equal to x is given by the point with coordinates xy is transformed to the point with coordinates yx. Let us consider the following example. Graph f of x is equal to 3x minus 2, find its inverse and then graph its inverse on the same set of axes. Show solution points for both functions. First we shall graph this function given by f of x is equal to 3x minus 2. We can rewrite this function as, now f of x can also be written as y. So we have y is equal to 3x minus 2. Let us make its table of values. When we put the value of x as minus 1, we get the value of y as 3 into minus 1 minus 2, which implies that y is equal to minus of 3 minus of 2, that is equal to minus 5. So for x is equal to minus 1, y is equal to minus 5. If the value of x is 0, then the value of y is equal to 3 into 0 minus 2, which implies that y is equal to 0 minus 2, which is equal to minus 2. So, for x is equal to 0, y is equal to minus 2. Similarly, for x is equal to 1, y is equal to 1. For x is equal to 2, the value of y is equal to 4. For x is equal to 3, y is equal to 7. Now, let us plot these points on the coordinate plane. Now we have plotted these points on the coordinate plane and we join these points to get a straight line. Now, this straight line represents the graph of the equation y is equal to 3x minus 2. Now let us find its inverse. Now we shall find the inverse of the function f of x is equal to 3x minus 2. Here, first of all, we replace f of x by y and we get y is equal to 3x minus 2. Now we switch x and y and we get x is equal to 3 into y, that is 3y minus 2. Now we shall solve this equation for y and we get x plus 2 is equal to 3y, which further implies that 1 by 3 into x plus 2 the whole is equal to y. That is, we have y is equal to 1 by 3 into x plus 2 the whole. Now we replace y by f inverse of x, and we get f inverse of x is equal to 1 by 3 into x plus 2 the whole. Now we graph this inverse function, and we know that it will be a reflection in the line y is equal to x. Let us draw the line y is equal to x. Here, this black line represents the graph of the equation y is equal to x. Now, if we interchange the values of x and y in the above table, then this will be the table of values for the inverse function. Now, let us plot these points on the coordinate plane. Here we have plotted all these points on the coordinate plane, and now we join these points. Now, this is the required graph for the inverse function given by f inverse of x is equal to 1 by 3 into x plus 2 the whole. Thus we see that the two graphs are the mirror images across the line y is equal to x. Now we shall learn how to find the inverse by restricting the domain. Let us consider the function f of x is equal to x square. Its inverse will exist if it is one-to-one function. That is, when we find its inverse, then value of y should not be in terms of plus minus sign, because it indicates that for one value of y, there corresponds two values of x. So inverse found will not be a function. So let us find its inverse, where domain is x belonging to the set of real numbers. Now here in this function we replace f of x by y, and we get y is equal to x square. Now we switch x and y, and we get x is equal to y square. Now solving this equation for y, we get plus minus square root of x is equal to y, or we can write it as y is equal to plus minus of square root of x. So, we write f inverse of x is equal to plus minus of square root of x. Therefore, it is not one-to-one function. Since it is having two x values corresponding to the same y value. Now if we see here, the domain is all real numbers. Now if we want to find its inverse, we will have to make it one-to-one function by restricting its domain. Now we restrict the domain of the function y is equal to x square to x is greater than or equal to 0, and now we try to find its inverse using the same procedure. Now we have this function y is equal to x square provided x is greater than or equal to 0. Now we switch x and y, and we get x is equal to y square. Now solving it for y, we get square root of x is equal to y. See, since we have taken the value of x as greater than or equal to 0, so we will not take value of y as plus minus square root of x. We have taken only positive square root of x. We can write this equation as y is equal to square root of x. So now f inverse of x is equal to square root of x is the inverse of f of x is equal to x square for x is greater than or equal to 0. We also notice that there is no plus minus sign because we have restricted the domain to x is greater than or equal to 0. Thus, we can find the inverse by restricting the domain of the function. Thus, in this session we have learnt how to graph the inverse of a given function whose inverse exists and how to produce an invertible function by restricting the domain. This completes our session. Hope you enjoyed this session.